Hi everyone. So now we are going to discuss question 19 of the exam questions. So this question is about longitudinal wave and transverse wave. State the difference between a longitudinal wave and transverse wave. So for this one, the differences, the first is the directions of the vibrations of particles and the directions of wave propagates. So the first mark is for the longitudinal wave, we know that the vibrations of particles is parallel to the directions of the wave propagates. But for transverse wave, the vibrations of particles are perpendicular to the directions of the wave propagates. Well, for the second mark is the longitudinal wave cannot be polarized and the transverse wave can be polarized. Okay. B. Give the definitions of a progressive wave. So when we talk about progressive wave, means the waves are in motion, which the motions have the directions. So how do you write the definitions? Which you have to write the wave whose wave profile moves in the direction of wave propagation. So for the keyword is the wave moves, wave profile moves, and the directions of the wave propagation. Okay. So for question C is about calculation. The first progressive wave is represented by the equations y equal to 0.40 sine 25 t minus 8s, where your x and y is in meter and your t is in seconds. So for this equation is basically in SI unit, so no worry, no conversions of units. So determine the amplitude. So from here, the equations, we will know that this one is the amplitude. So your amplitude is equal to 0.40. So amplitude must be in SI unit, which is meter. So 0.10 meter. So for frequency, how do you get a frequency? So question number 2, frequency. So we know that sine omega t minus kx. So from here we know that omega is actually 25. So omega is equal to 25, which we know that omega is 2 pi f equal to 25. So f will be equivalent to 3.98 hertz. Okay, so substitute your omega equal to 25, so you will get your f is equal to 3.98 hertz. So you can leave the answer as 3 significant figures or 2 significant figures, because your least significant figures here is 2, so you can leave it as 2 or 3. And then for question 3, we want to find the wavelength. So how do you get your wavelength from k? For the constant k here, because k is equal to 2 pi over lambda. So we know that k is equal to 8 from the equations. We know that k is equal to 8. So k is actually 2 pi over lambda equal to 8. So your lambda will be equal to 0.785 meter. So you can leave the answer as 0.785 meter, or you can leave the answer as 2 significant figures, which is 0.979 meter. Sorry. Okay. No dot here. Okay. So for the fourth question number 4. So you want to calculate the speed. So how do you calculate the speed? Because you already have your f and also lambda, so v will be equal to f lambda. So don't take the 2 significant figures, so take at least 3 significant figures. So you have 3.98 times 0.785. So you will get your answer as 3.12 meter per second. Remember, your equation is in SI unit. So your answer should be in SI unit. So you can leave the answer as 3.12 meter per second or 3.1 meter per second. So question number 5. The directions of the wave propagation. So where is the directions of wave propagation? So we refer to the sign of your K, which is negative value. So remember that for negative value is travel in positive x directions. Okay, it's a positive OX directions, or you can answer it as to the right. Okay. Number 6. So number 6 is about the displacement y at a distance of 0.3 meter when t equal to 0. So the distance here means value of x. So when you want to calculate y, when your x is equal to 0.3 meters. So very easy. Take the equations above. So you have y equal to 0.40 sine 25t minus 8x. So you are given t is equal to 0. So substitute inside y 0.40 sine. So you left negative 8 sine 0.3. So you get your answer y as equal to negative 0.27 meter. Don't forget your negative sign because here you have negative. Okay? And that question number 7. So for question number 7 is calculate the phase difference between 0.35 meter and 1.25 meter. Means this is your x value. You have x1 and x2. So you want to find the phase difference. The difference is phase difference, so you have to find the phase constant at 0.135 meter minus phase constant at 1.25 meter. So use this relation. So what's your phase constant? So phase constant is equal to kx. So this one is kx 0.35, this one is for your kx 1.25. So your k is 8 here, refer to here, k is 8. So now x is equal to 0.35 minus 8 times 1.25. Because difference means you have to modulus it. Because you are using the larger value minus the smaller value. So you will get your phase difference at 7.2 radian. So remember, phase difference, the unit is in radians. Question number 8. Write the wave equations for a progressive wave having twice the amplitude. So now your new amplitude is twice the original one. And you have the twice the frequency, so your new f will be equal to 2f, and which is moving in opposite direction. So moving in opposite direction means your sign at here, notice here, become positive value. So we have to find out the equations. So change the value first. So your A naught mu A will be equal to 2 times 0.40, which is equal to 0.28 and 0.80. Now your omega, the new omega will have 2 pi f prime. So your f prime is 2f. So 2 pi times 2f, which is 3.98, the original f at here, which you get it in your second part. So you will get the new omega as 50 radian per second. Well, how do you calculate your lambda? So your lambda can be calculated by using your V. So your V is still the same because it doesn't change in median. So your V is always constant because there is no change in median for travel. The wave doesn't change in median for traveling. So same median because of the same median here. So V is constant. So V is equal to F lambda. So your very initial V, you can refer to question number 4, which is 3.12 meter per second. So your new F is 2 times 3.98. So your new lambda will be equal to 0.39 meter. So after you calculate, you will get your new lambda as 0.39 meter. Then, of course, because for your equations, okay, so let's draw a line first so that you don't confuse. So because your new equation, y is equal to a naught mu, sorry, not a naught, mu a, sorry, this first, mu a sine the new omega t. So this one is your new omega t. Sorry, I just forget to write down the new omega. So because it's in opposite direction, so it must be positive instead of negative, because initially you have negative sign. Okay, plus kx. So of course this is your new k. So in order to get the new k, so k prime will be equal to 2 pi over lambda new lambda. So your new lambda is 0.39. So you will get your answer as 16.1 and substitute your omega and a into this equation. So you will get 0.80 sine for omega t is the new omega is 50 t plus k new is 16.1 x. So this is your answer. Okay, is it clear? So that's it for this question.